Welcome back students in the third part of this series. Here I am going to discuss about work done, its unit, formula for work done, different forms and kinds related to work done and its calculations. So let's start. In the language of physics, we can say work done by force acting on an object is equals to the magnitude of the force applied multiplied by the displacement of the object in the direction of the force applied. Or you can say in short, work is said to be done when an object is displaced on applying a certain amount of force. Therefore, we have the formula of work done as the product of force and displacement. Its SI unit is joule as per to energy. When we need to define 1 joule of work done, we can say 1 joule is work done when the net force of an 1 Newton acts on a body to displace the body by 1 meter in the direction of force applied. The CGS unit of work done is erg. Again, it is same as to energy. I hope you remember from the previous parts that energy is the capacity to do work and energy is the cause, whereas the work is an effect. Therefore only we observe the same unit for energy and work done. Now let's understand work done by a constant force. As just now we had discussed, work is said to be done only when the force is applied on a body makes the body move, or the amount of work done by a force is equals to the product of the force and the displacement of the body in the direction of the force applied. Thus, we get it as the force applied on a body and the displacement made by the body are the two most important factors for the calculation of work done. But for a constant amount of force to cause a work done, the direction of the force applied with respect to the direction of the displacement made by the body is also very important. See, if we have the displacement made by the body in the direction of the force applied, then our formula for work done is as the product of force and displacement. But if the direction of the force applied is something else than respect to the direction of the displacement made by the body, then the formula changes to the product of force cos theta and displacement. Let's understand more about this. Here you can see the girl is pulling this box in the upward direction, whereas the body or that box is moving parallel to the surface. Therefore, we have two different conditions. The direction of force is different in respect to the direction of the displacement. Under this kind of situation, we use an angular theorem, and that is the theta formation, which is referring to the angle between the direction of the force applied and the direction of the displacement. For this kind of situation, we take a component of force. A component of force you can say as the resultant force or the effective force on a body. Say as for example, when the force been applied in a certain angle with respect to x-axis and y-axis, then to the x-axis, if the body is displaced over here, then the angle which is forming, it will cause a component of force which is referred to the Pythagorean theorem. Here, if we make a right angle triangle, then we will have the hypotenuse as the pathway of the direction of force applied and the base will be the direction of the displacement. And the ratio of base and hypotenuse is known as the cos. Therefore, we get the value of theta as cos theta and the component of force is named to be as F cos theta. Therefore, the angular formation of work done can be calculated with this formation as F cos theta S, where F cos theta is the component of force and S is the displacement of the body. You will understand more about this when you will study vector. Now, let's understand the three forms of work done as positive, negative and zero. When force and displacement are in the same direction, then the calculatable work done is positive, such as when a body moving in an horizontal surface, the direction of force applied and the direction of the displacement is in the forward direction, then the calculatable work done will be positive. Whereas if the body is moving in completely opposite direction to the force applied, then the calculatable work done will be negative, such as work done by the gravity on a rocket going perpendicularly upwards. Whereas work done can be zero when the force and displacement are perpendicular to each other, or when the force or displacement is zero in itself, then the whole calculation will be zero, means the work done will be taken as zero. Here you can see some of the relation between the angular motion with respect to the positive, negative and zero situation of work done. Students, remember, if the direction of the force applied and the direction of the displacement is same, means the angle between each other is 0 degree, then we will get a positive maximum work done. Whereas if the body is completely moving in the opposite direction of the force applied, such as the angle become as 180 degree, then we will obtain a maximum negative work done. Work done against gravity. Yes, you can do work done against gravity. When you lift any object to a certain height, then you actually do a work against gravity, which can be calculated with the formula as mgh. Now let's understand what is the relation between mgh over here. As we know that work done is equals to force into displacement, but we can derive F as mg also because it is the product of mass and acceleration. And when you are lifting any object in the upward direction, then the acceleration being taken as the acceleration due to gravity, and the displacement will change to the height till which you had lifted the body. Now, when you had gone through the formula of mgh, you may remember with one term which you had studied earlier, that is the gravitational potential energy. Yes, work done against gravity is also said to be as the gravitational potential energy. Now, work done in a circular path. So, let's understand one question. What is the amount of work done by a force when a body is moving in a circular path? So how would you answer this? You can say the work done on a body moving in a circular path is zero. How this is possible? This is possible because when the body is moving in a circular path, then the direction of the centripetal force which is acting inwards the circle and the direction of the motion or the path of the inertia is perpendicular to each other. And just now we had discussed this thing that if the value of cos theta comes to cos 90 degree, then we will get the value as 0 degree when the work is said to be 0. Now let's understand some of the very simple numericals on the basis of work done. This will be a small revision for you all. Such as the first one, a person pulls a block of 2 meters long on a horizontal surface with a contact force of 20 Newton. Then determine what is the work done by the force F. So what are the things given to us? We have the force as 20 Newton, the displacement made by the body as in 2 meter, and the angle is given as 0 degree. Now why I had taken here as angle 0 degree? Because there is nothing been mentioned in the question whether the direction of the force applied and the direction of the displacement made by the body is in any other direction. So we will take it as the both are in the same direction. So here when we place the quantity in the formula, we will get the quantity as 40 joule. Now move to the next question. A force of 10 Newton acting on a box which moves it by 1 meter along a horizontal surface, then the force acts at 30 degree as shown in the figure. You can see over here that the direction of the force applied and the direction of the displacement is in two different form, which I was discussing in the previous one also. In the previous one there is no such kind of condition. That's why I had taken the angle as 0 degree. But here you can see that the direction of the force applied and the direction of the displacement is with reference to 30 degree. So therefore we have something else over here, that is the cos theta will be taken as cos 30 degree, and when you will place all the quantities over there, then you will get your final answer as 5√3 joule. Now let's see the last question. A body falls freely from rest of mass 1 kg from a height of 2 meter. If the acceleration due to gravity is 10 meter per second square, then you need to determine the work done by the force of gravity. Now, how you can solve this? Again, I would request you all to write all the quantities what is given to you. So here, the mass of the object is 1 kg. The height from where it been dropped is 2 meter and the acceleration due to gravity is 10 meter per second square. Now let's see the solution. As we know, work done is equals to the product of force and displacement. But here in this question, we are not having the force directly. But yes, you have the calculation which is necessary for the force. What you need to do? You just need to substitute this force with the weight of the object. And the weight of the object can be calculated by the product of mass and acceleration due to gravity, because as you know, the weight is a force due to gravitational pull. Now the displacement of the body will be taken as the height, because earlier only I had discussed this thing, that when the work been done against the gravity, then the height till which the object been lifted or from the height where the object is falling down will be considered as the displacement made by the body. Now I hope it will be very easy for you to do the calculation. Just place the quantity as mgh with their numerical value, and then at the end you will get your answer. Now there is a brain teaser for you all. Please all of you go through this question and see whether you can solve this or not.